Hello, Professor. We are Group 28. My name is Zhao Qian, and let us introduce our project, Recommender System of Jokes based on the content-based and collaborative filtering algorithms. First of all, let me introduce our project introduction. In this report, our purpose is to try to find high-quality user feedback to improve the quality of recommender systems and help the producers to give more interesting jokes and improve user loyalty, prevent user loss, and increase the revenue of the website in a potential way. Let me introduce the problems and the challenges. It may have some problems that the rating matrix is sparse because many users do not rate projects or rate only a small number of projects. This reduces the likelihood of currently finding a similar set of users. It may have a cold start problems. This is a problem to face the new items and the new users. It may also have a scalability issues. The performance in the large data set is not good, or the execution efficiency is much lower. And it may also have a problems of diversity. And then I will introduce the advantage of these algorithms. The content-based recommender systems provide user independency by developing the information into a user profile by considering the user's performances and the user's interaction. It is very useful for new users because it can recommend new items with no rating in the past. And another collaborative filtering that is the most frequently used method to design recommender systems. The different methods may have different advantages. Memory-based method can add data more easily in an incremental manner, making it easier to implement the systems. Model-based method can improve the accuracy of prediction results and avoid some drawbacks such as scalability and sparsity. And then I will introduce the methodologies. We use the three main methodologies. The first one is SVD. The SVD-based recommender systems should combine the calculation method of a vector similarity, finding the user's project's score similar to the user to be recommended, or finding a project with a higher ranking than the user to be recommended. And the second one is a cosine similarity. Another commonly used distance calculation method, which calculates the cosine of angle between two vectors. And the third one is k-nearest neighbors. The features of the test data are compared with the features to the training dataset, and the similarity of top 5 to the training dataset are founded. So let me partner to introduce the next part.
Hello, my name is Zhang Xiaoyi. Now let me introduce the dataset used in our study. The empirical research in this paper is mainly based on the three datasets about the recommender system named Jester. The first column means the number of jokes the user have evaluated yet. Then the remaining columns are the user's scores for different jokes with a real number range between -10 and +10. Rating 99 indicates null. We set to NaN and the first step of pre-processing. Then it's about the splits of train and test from original data. Firstly, in k-nearest neighbor algorithms, we set k equal to 5 to find the correspondence between each data in a sample set and its classification based on training sample set. In the rating file, the space between two columns is 2 tab. So we double the parameter set. By reusing different random packet data for cross-validation, We set a part of the data in the original data to hold out set and carry out the whole process of CV in the rest. Besides, in K-force cross-validation, we split the data into K different subsets by using 5-fold cross-validation in this study. And then we use the fourth subset to train the data and leave the last subset as the test data, calculating the average for each subset model and then end the model to test the test set. However, we also have some limitations in our current study. Firstly, on one side, it would be difficult for us to adjust our percentage of freshness, since people may keep on staying within the preference field, which are beneficial to them. Secondly, as for the security, we also need to find a better balance between recommendation and privacy data protection. In addition, how to avoid users' malicious evaluation and the deviation of the recommender system results, and how to make those users who are inconsistent with any group of people benefit from the recommender system would be taken into more considerations, which requires more breakthroughs. Also, there are still some areas to be improved in the future work. We proposed the probabilitist matrix factorization to train these models efficiently and successfully. In the future research, we can use to enhance the accuracy of prediction, and we also need to improve the infrastructure information of data, since we cannot average the specific characteristics of the instance sample and the typical instance sample. That's all. Thank you. Now let my another partner to introduce the next part.
Hello, my name is Wang Wei, and I will briefly demonstrate our code. First of all, I will do some data process of our data set. As you can see, the original data set of just the data set 2 is like this, and we want convert it into the data set like this one. So I use pandas to convert the rating tables like this one, and for the jobs content, we can find the jobs is like this with a lot of HTML tags. So in this part, I use beautiful soup to remove all the HTML tag and convert it as a list. Next, I will introduce the CFS file, which is our mainly algorithms, the neighborhood method. For these classes, we pass 4 parameters to these classes, which including the ratings, which has been formatted, the test user ID, the most corrected n neighbors we need, and the threshold, which decide which value to output. And first of all, I calculate the cosine value between the test user and the rest to decide which users we should choose, and then we sorted the cosine values, and we choose the most the nearest n neighbors, which is decided by this value n, and then we check the unrated joke IDs of our test users to decide to check those items without ratings, and we take out those joke items and find the ratings of them in the most nearest in the nearest neighbors, and after that we can output uh, this rating joke items, and we check the ratings between we check the ratings of it and the threshold to check whether this rating is bigger or smaller than the threshold. If it's bigger than the threshold, we choose those items as our recommended jokes. So next, I will show the how we make it output. For example, our test ID is 1778, and we set the threshold as 5, and we choose the most related 5 neighbors, and we want to output the content of our users, which we want to recommend to the test users. So we run this program. Yeah, we can see that we get the joke ID 106 and the exactly content, the strings of these jokes. So we also do something like the implement of surprise to use another method, which is SVD, and we improve the performance of SVD by using the grid search CV algorithms. And in order to improve the processing data speed, I also do the PCA, which is the dimension reductions, and that's all these things. And to conclude, we implement the SVD algorithm, which could do the demonstration reduction first into our project. This would be a useful way to reduce the time of generating similarity of users greatly when we choose a reasonable singular value. However, on the other side, when it comes to the accuracy discussion, if we choose to use RMSE SVD algorithm would not be taken into consideration, since there would be less advantages on using it. In the whole recommendation system, we use cosine similarity and SVD algorithm to calculate the similarity. Then we can find out items without ratings and recommend the items based on similarity choice. That's all. Thank you.